mathematicians, this is Mrs. Shopper coming to you with our first part of chapter 6. It's Angles of Polygons. We're going to be talking about quadrilaterals. We're going to take a break from triangles and we're going to move into quadrilaterals, okay? So when we're looking at this, so first of all, the note cards are going to be on here again. So you make sure that you're taking a look at what you need to put on your note cards. We're going to continue to do that, continue to get you a study strategy that you can use to work on that. So the first theorem we're going to be talking about is the polygon interior angles theorem. It's building on what you talked about in 7th grade about finding the total sum of the angles in a figure. And the formula that you're going to use is going to be the number of sides minus 2 times 180. All right, so if it's a pentagon, as the example is here, you're going to go 5 minus 2, that's 3. Take 3 times 180, and you're going to get 540 degrees, okay? The reason why we do that is because we have, when you draw the number of triangles in the figure, there's 3 triangles. There's always going to be 2 fewer triangles than there are sides. And so that's why we know triangles have 180 degrees. That's where that formula comes from. Okay. And so when you draw your diagonals, you're creating those triangles. Okay. So it's the number of sides minus 2 times 180. Okay. So if we're going to find the sum of the measure of the interior angles of a convex, ooh, that's coming back from the beginning of the year. Convex means all the sides push out. They're not caving in. That would be a concave figure. A convex nonagon. It is important that you know what the prefixes are. Nonagon is a 9-sided figure. So to find the sum of the measures, we're going to take 9 minus 2, and that's 7, and we're going to take 180 times 7. And so 180 times 7, because that calculator isn't working, we're going to go to plan B. Here we go. We're going to take 180 times 7. And we've got 1,260 degrees, okay? Now, if I wanted to figure out how much each angle would be if it was a regular nonagon, that means that all of the angles are the same, then I would divide that number by the number of sides, which is 9, okay? So if I want to find out what each angle would be if it was regular, I would divide it by 9. Okay, find the sum of the angles in a convex dodecagon. A dodecagon has 12 sides. So we're going to take 12 minus 2, which is 10, times 180 is going to be 1,800 degrees, 1,800 degrees. Find the measure of the interior angle of a regular polygon is 150. I said that wrong. The interior angle of a regular polygon is 150. We need to find the number of sides, okay? So we know that 150 is equal to the sum divided by the number of sides. And we don't know the number of sides right now, okay? Well, how do I find the total sum? The total sum of the interior angles is going to be the number of sides minus 2 times 180. So I'm going to replace this into my formula. So I'm going to have 150 is equal to the quantity x minus 2 times 180 divided by the number of sides. Okay, so I have an equation. I have only one variable, and so now I can go ahead and solve that out. I'm going to multiply both sides by x because I want to cancel my fraction, 150x. I'm going to distribute is equal to 180x minus 360. I'm going to keep solving this equation for x. And so negative 30x is equal to negative 360. I'm going to divide both sides by negative 30. And I'm going to get that x is equal to 12 sides. Okay, so 360 divided by 30 is 12. We have 12 total sides. And again, we're using, let's shrink that down a little bit. There we go. And I should probably make sure I have this all written out. There we go. Okay, So we're solving that equation out. So again, what we're talking about, you take the sum divided by how many sides. If you don't know how many sides, you got to make sure you use that for x. Okay. Find the measure of the interior angle of each interior angle for this parallelogram. And so this again is building on the sum of all of the interior angles of a quadrilateral is 360 degrees. If we don't remember that, we take 4 minus 2 is 2 times 180 is 360. Okay, so what we're going to do is we're going to add up all these sides. So 2 times the quantity 11x plus 4 plus 2 times the quantity 5x is going to get us to 360 degrees. And we solve this equation out. So 22x plus 8 plus 10x equals 360. I'm going to subtract 8 from both sides. So I have 32x is equal to 352. And I'm going to take 352 divided by 32. And I'm going to have 11. X equals 11. Now the question says find the measure of each interior angle. So now that I know that x is 11, I can figure that out. The measurement of angle R is going to be 55. The measurement of angle T is the same thing at 55. The measurement of angle S is 11 times 11 is 121, plus 4 is 125. And the measurement of angle U is also 125. Okay, so not a lot new. In fact, most of this is review, but it was from 7th grade, which was a couple years ago. So, or 7th grade math, which was a couple years ago. So it's good to have that, you know, kind of come back and help us out with it. The polygon exterior angles theorem, the sum of all the exterior angles of a polygon is 360. Okay, notice the note card. That's another one you're going to put down. The sum of the exterior angle measures is 360 degrees. So here's a question that's asking us to find what x is. Well, we know that the sum of all of these is 360 degrees. So 5x plus 4x minus 6 plus 5x minus 5 plus 4x plus 3 plus, I'm running out of room, 6x minus 12 plus 2x plus 3 plus 5x plus 5 all equals 360. So I'm going to add this up. 5x, 9x, 14x, 18x, 24x, 26x, 31x. So if I added that right, it should be 31x. And then I'm going to add up all of my constants, combine those together. So -6, -11, -8, -20, -17, -12. And that's going to equal 360. So I have 31x equals 372. So 372 divided by 31 is 12. X equals 12. All right. So that's your lesson on working with quadrilaterals and angles. I hope you have a fantastic day, and we'll catch up with you soon. Take care, mathematicians.